Everyone, my name is Upadesh Sai, and today I'm going to do the week 3 reflection for software engineering. This week, the lecture introduced chapter 2, building a system, and I want to be honest, before this week, I thought writing a code and building a system were basically the same thing, just code, right? Wrong. This week showed me exactly why those two things are completely different, why an entire discipline called software engineering exists to deal with that difference. What I learned, breadth versus depth of complexity. The first big concept from this week was complexity. The lecturer broke it into two types, breadth and depth. Breadth is about the sheer numbers. As a system grow, you get more functions, more features inside each function, more interfaces connecting to other systems, more users, more types of data to handle. Breadth just keeps expanding outward. Depth is a different kind of problem. It's about how connected everything is, the linkages between components, the data they share, the control they passes between them. These connections can be hierarchical, sequential, recursive. They go downward into each other. The deeper the system, the harder it is to understand what one change will do to everything else. The lecturer showed us a simple diagram, a straight flow on one side and on the other, a system with waiting states, signals, loops, and branches. Same concept, completely different complexity. That visual really made it click for me. And what surprised me the most, the lecturer said this complexity increase happens everywhere, in the problem, in how we try to solve it, and in the final solution itself. You can't escape it. You can only manage it. Program versus system, the real difference. The second thing I learned this week was the difference between writing a program and building a system. And also I want to be specific here because it changed how I think about our group project. Writing a program is something one person does, one developer, one set of logic, a known number of users, limited connections, and manageable. Building a system is completely different. A lecturer told us that system can have hundreds and thousands of components. It requires a team, sometimes 50 to 1,000 people depending on the project. And when you scale a team, something unexpected happens. Communication does not just get little bit harder, it explodes. The lecturer showed us a formula. The number of communication paths between n number of people equals n times n minus 1 divided by 2. So what it means is, so if you have 5 people, you have 10 possible communication paths. If you have 10 people, you have 45. Add more people, the coordination overhead grows faster than the team does. More paths means more chances for miscommunication, errors, and everything. To talk about more, the lecturer also warned us the first time you adopt a proper development process, it actually feels more complex, not less. Because you're learning the process while doing the work, but he was clear it pays off. So linking to software engineering project, how does this all apply to our actual group project, directly or very indirectly? Our group is currently in early stages of assessment 2, requirement, initial design and project planning. What I think about breadth of the complexity now, I'm asking different questions. How many features are we committing to? How many user types will interact with our systems? How many interfaces do we need, internal or external? I want to understand that each of those numbers is a complexity multiplier. On the depth side, I'm thinking how our components will share data, where is control passed from one module to another. If we change one part of this system, what else breaks? The lecturer's point about hierarchical relationships, how many levels deep our design goes, is something I'm going to bring into our architecture discussion. So on the people side, we are a group of 3. Using the formula, using a group of 4, and using the formula, there are 6 possible communication paths, not huge. The lecturer point stands. We need a process. We need to know what does what, how we report problems, how we make decisions. Otherwise, we'll spend more time in confusion rather than building. So now in the last part of this reflection to close, what did this week teach me? It taught me that software engineering is not about writing smarter code. It's about managing complexity in a disciplined, structured way so that a team of people can build something together that none of them could have built alone. So breadth and depth of complexity are real forces. A system is not a big program, and the moment you add more than one person to a project, you have entered the world of software engineering with all the processes, tools, and coordination that comes with it. I'm going into our group project this week with a clearer picture of what we are actually building, not just writing a code, but engineering a system. And I now know what the difference actually means. Thank you for watching.